Welcome back to chemistry. We are still talking about mole conversions. Last time we left off, we were looking at converting mass to volume here, okay? This was a two-step conversion. We went from mass to moles, that's one step. Then we went from moles to volume, that's two steps. Before that, we learned that 1 mole is equal to the molar mass, or GFM, in grams. That's when you break apart the compound and add up all its weights from the periodic table. 1 mole is equal to 6.02 times 10 to the 23rd. That's a how many number. Just like dozen equals 12, mole equals 6.02 atoms, molecules, and particles. We also learned that 1 mole is equal to 22.4 at STP, standard temperature and pressure. Don't worry about STP. Everything you do is at STP, so you can just use 22.4. Today, we're going to be looking at how to convert between mass and molecules. Look at example number 1 here. I have 54 grams of water, and I want to know, if I have 54 grams of water, how many molecules do I have? So let's take a look. Well, I'm starting off in mass right here, but now I've got to get to molecules, which are right here. I'm going from mass to molecules. Remember, when you're doing any conversion problems with moles, all you care about is 2 things, your starting point and your ending point. All I care is my starting point and my ending point. The starting point they should give you a number for, and then they should tell you they want you to go somewhere like moles, atoms, liters, or whatever. So that's all you care about, your starting point, ending point. So I'm going to map out what's happening here. I got to first convert from grams to moles. And then I have to convert from moles to molecules. So that's 2 steps. All right, let's break this problem down now. To go from 54 grams to molecules, I just showed you that it's a 2-step problem. So I'm going to use dimensional analysis. Dimensional analysis is when we use that grid system. So I'm going to start off with 54 grams of H2O. Okay, that's easy enough. And then what I'm going to do is I'm going to draw my boxes. Since it's a 2-step problem, 2 sets of boxes. So whatever's up here always goes down there. Before we do anything to these boxes, we got to fill them up with units, okay? Not numbers. You always save numbers for last. All we care about is the units. So whatever's up here goes down here. So I got grams here, so I'm going to go grams there. Okay, good. Now, if we're not in moles, remember what I told you. You always convert to moles first. And on that mole diagram, we got to go from mass to moles anyway. So you always go to moles first. So we're going to go to moles. Now, same thing with this box. Whatever is up here goes down there. So I'm going to put moles here. And finally, where did they want me to go to? They wanted me to go to molecules. Really simple. I'm telling you guys that this chart fills itself out. They give you the first unit. You know that first unit goes down here, and you know you go to moles first. Whatever's up here goes down here, and then you can go to wherever it is they told you to go to. Now it's time to plug in numbers. To plug in numbers, we're going to use our conversions right here. 1 mole equals this stuff. This is what you're going to use. That's where the numbers come from. So let's start with moles first. These 2 moles, what does moles always get? Moles always get 1. Let's do the molecules. Molecules, atoms, molecules, and particles always use 6.02 times 10 to the 23rd. And finally, grams, if we see grams, we got to use the GFM. That's where we break apart. So I got to calculate the GFM so I can plug it in right here. So I'm dealing with H2O. That means I got 2 H's and 1 oxygen. I know that hydrogen weighs 1.008 times 2, so that gives me 2.016. Oxygen weighs 15.999. I only have 1 of those, so that's 15.1.999. That gives me 9 plus 6 is... Okay, so after doing the math, all I did was 2 hydrogens, so I got the mass of 2 hydrogens. 1 oxygen, the mass of 1 oxygen, you add it together, and you get the GFM, the molar mass, of 18.015. So here's where I plug in right here, 18.015. Now, So remember, now it's time to do the math. We got to multiply the top together. We're going to get a number. We're going to multiply the bottom together. We're going to get a number, and we're going to always divide last. So let me get my calculator. I'm going to calculate now. So when I calculate the top, 54 times 1 times 6.02, I get 3.25 times 10 to the 25th power. I'm going to multiply the bottom together. 18 times 1 would give me 18.015. So now I'm going to divide. I'm going to take 3.25 times 10 to the 25th divided by 18.015. So that'll give me a final answer of 1.80 times 10 to the 24th molecules. So what this is saying is, if I have 54 grams of water, I actually have 1.8 times 10 to the 24th molecules of water. That's a lot of molecules, guys. A lot of molecules. So that's how you go from grams to molecules, or mass to molecules. Now let's reverse this process. Our next example here, if we're looking at it, they're starting us off with molecules and they want us to go to grams. So for this example, we're going from molecules to grams, or mass. So this time, we're starting off in molecules right here, and they want us to go back to mass. So if I'm in molecules, where do you got to go to first? You got to go to moles first, and once you're in moles, then you can go to mass. So this is a two-step problem. From molecules to moles, from moles to mass. So let's do our dimensional analysis again. They start us off with 1.204 times 10 to the 24th molecules. I know that this is a two-step problem, so I'm going to draw two sets of boxes here. Let's fill this out. Units first, okay? So I'm going to go from molecules. Whatever's up here goes down here, so I'm going to say molecules. Where do we always go first? You got to go to moles first every time. Moles. Now that I'm in moles, I can go to my unit grams. Whatever's up here goes down here, moles, and then we can go to grams. Guys, no matter what conversion you're doing, it's the same thing. Whatever unit they give you, go down here, you go to moles first. Moles go down here and here, you go to the unit they want you to go to. But remember, if they told you just to go to moles, you would stop at moles. Right there, that is all you would need, is this part right here. Right? If they told you to stop at moles, whatever's on the top last box is where you stop at. But they didn't want me to stop at moles, they wanted me to stop at grams, so I got to do that last step from moles to grams. So now it's time to plug in numbers. Again, we're going to use our conversions right here. Moles always get what? Moles always get 1, so I'm going to draw in 1 mole. Molecules always get the 6.02 times 10 to the 23rd. And then grams always use the molar mass. And we're going to hit, I didn't give you a molar mass here, but I'm going to just use the same for water. Right? We got that many molecules of water. So we'll use the same molar mass. The molar mass we've already calculated here. We have 2 hydrogens, so 2 hydrogens weighs that much. 1 oxygen weighs that much. So when I add it all together, that's the molar mass. So I will plug in 18.015. We will always give you guys, if you're doing a conversion that requires the molar mass or the GFM, this guy, you'll always be given the formula, H2O or whatever, but you still have to break it apart to get the mass. So now, our last step, let's do the math. We're going to multiply the top together. We're going to multiply the bottom together. So let's do that now. And you always save dividing for last. So I'm going to pull out my calculator and calculate. So if I go 1.204 times 10 to the 24th times 1 times 18, you're going to get 2.169 times 10 to the 25th. And then 6.02 times 1 is 6.02 times 10 to the 23rd times 1, so it stays the same. Now my last step is to divide. So when you finally divide 2.169 times 10 to the 25th divided by 6.02 times 10 to the 23rd, you're going to get 36 grams of H2O. Okay, easy. So if I have 1.2 times 10 to the 24th molecules of water, that is actually equal to 36 grams of water. That many molecules weigh that much, okay? That many molecules weigh that much. So guys, this is how you convert between mass and molecules, both examples. So guys, I would take this time, if you're still confused, to stop, rewind, and watch it again. But the steps never change. They give you a given number. Whatever's up here goes down here. You always convert to moles first, unless you're in moles, then you just go to wherever. But then whatever moles to moles, whatever's up here goes down there, and where they want you to go goes up top. It's the same thing every time, guys. This is how you calculate mole conversions, 2 steps, mass and molecules. Hope this helps. Have a great day.